Hey guys, and welcome to another Forts Advanced C++ tutorials. Today we are continuing on with down a path that we started up with the last installment in the tutorial. We were looking at how to compile Lua scripts. Now, without mentioning it yet last time, the truth is the compilation does complicate the project quite a bit. And I didn't mention it because we're going to look at that today and solve it. But the solution actually leads to a much more dynamic and scalable system overall anyways. So it's kind of an overall positive. Now, if you think about it, or if you work on a project for a while and then try to switch over to compiled files, you're gonna find you're gonna realize what this problem is, and that's that the way the code gets loaded and executed is quite a bit different after compiling it than it is before compiling it. Take a look at what we're doing right now. We've got this main Lua file, and then we call it. We load it in, and we call it. That's how we've been creating and debugging our application all along. If we needed other files involved, we could just use the require function, like so. And by the way, I kind of never mentioned this, but it is more convenience of Lua, a much more convenient way of calling require, and that's that if a function only has one argument, and that argument's either a string or a table, you can drop off the parentheses from the function call, and the quotes or the curly brackets will act as the parentheses instead. So in this case, I can require like so. That is syntactically appropriate. Now, if I do that, as I was saying before I got sidetracked on the parentheses thing there, this means that once I've entered into main, perhaps I did something here, and then I did something else here, and in the middle of that I required in secondary so I could use some of the things it provides. But now we have a problem, because the way the compiler is probably going to do this is maybe main will be the first file. If you recall, we have these protos. The proto for main will become first, and the proto for secondary will be second, and there won't be a script called secondary.lua for it to require in, so the require here won't even do anything, and the secondary won't even be executed until after everything in this file is done. It'll be executed down here somewhere. So we have a kind of problem here, is that we've been developing under one mindset, and we've added compilation, and that doesn't seem to be compatible with the mindset we've been using. So what we need to do is look at this and figure out what the problem is. And if you take a look, you can think about this in terms of C++. The C++ doesn't work anything like the way we're trying to make Lua work. If I said that in C++ you start at the top of the main file, and first you execute the first line, and then you come down and execute the second line, and oh, we hit an include, so execute this file real quick. So start at the top of this file and execute from top to bottom, and then execute line 3, execute that file, come down here, execute this line, execute these things, compile, whatever happens when you execute this line doesn't really make sense. C++ is designed to be only a compiled language. Although Lua can work the way we've been making it work, and does work that way in many cases, a large-scale application might not be so feasible, especially once we start using compilation. Learning from C++, perhaps the correct solution would be to make it so that our entry point is not tied with this file. Perhaps after we've loaded and executed the main script, what we want to do is then execute a main function to actually enter into the program. That way, say we had a dependency problem like this, for example, a.j equals empty table, secondary a equals table, and it worked while we were developing because we were doing this, right? But as soon as we start compiling, secondary isn't being called until after this, and so we have a problem. If we do go with this fixed entry point solution, we would probably end up having to wrap this in a main function like so, and suddenly it's a non-issue, because even though this gets executed before this, right, and the require isn't necessary, because this got compiled, right, And then when this is executed, it doesn't actually call that function. It just creates a function that can be called later. So this function has been created, and it's going to be called after this thing gets executed. So it does seem to have solved this problem. But let's implement that and see where we go from there. That would go something like this. So we're just going to get whatever's paired up with main and call it. And what's paired up with main should be a function. Now, you probably saw that I had a third file that was called link, and that's kind of where we're going to go here. The compiler is basically doing a job of linking. It's taking all these different files, linking them up into one file. And as a consequence, if we don't do the same type of system, it's going to be very insensible to try to make the development in debug mode and development in release mode and the release mode work the same, because we're going to be developing just like with the entry point prop. We're going to be developing with one mindset, and then as soon as we compile, there's going to be a slightly different behavior. Now the behavior has gotten a lot more similar with this main function, but what's the other problem here? What is it that I'm saying, and what is it that needs this link file? It's the require function. If while I'm developing, I develop by saying require secondary, or even if I do it by saying require secondary at the bottom, the way the compiler will, this still doesn't make sense, because my compiled code is going to have the require function in it, and I don't want any calls to the require function if everything is going to be pre-linked. So what we really want is some way for everything to be pre-linked even now, even though I'm not in a compiled version. I'm in a like development debug mode. I still want everything to be pre-linked, and I don't want to have to compile every time. So what we need is a script, which is going to be link.lua, which can take the place of the compiler and go through all of the files and link them in. And that's what we will see when we look at this link file. Its job is basically, it makes this useFile function. UseFile is going to make a list of file names, the same way the compiler does. Every time I call useFile, it adds another name to the list of names to require in, and then it requires it. Now you might be wondering, why wouldn't I just call require on them directly? Because I could make my linker much more simple without this for loop and without having to define useFile. And as of now, that's true, but because of something we're going to do later, setting it up like this is actually going to help us a lot. This is going to help us to make our project more scalable. So we're going to use this. We're going to just trust me for now that this is what we're going to stick with. Let me check my time. Sweet. Okay, so far, what we've done is we've said we're switching to a more of a linked style thing. We're going to dynamically link all of our files in with this link.lua, and when we execute link.lua, it's going to go through and make a collection of file names and then require them in. And then once that's done, we should have one of those files should have included a main function to be called, and indeed main will have, and then we can call that. Let's just give this whole system a go round. Alright, let's see it work. And there we go. Works like a charm. So, we haven't even started using the compiling stuff yet, but we're going to actually compile pretty soon now. What we want to see next is how are we going to set up that compiler. That's what we're going to look at next. We've got a whole system for linking. Let's make a compilation system though. First of all, what we're going to do is we're going to use some macros to make two different modes so that we can compile an exe for compiling and compile an exe for debugging. And also compile an exe for running compiled code. So what we really have is debug mode. We've got compiler mode, and we've got release mode. And then what we're going to do is we're going to have a mode, and let's start by setting that to debug. So let's see. In debug mode, we don't need the compiler stuff registered. So actually, we only need this if mode equals compiler, right? So and if so, this will only get registered if we're making the compiler. Otherwise, no. Now, link.lua, that's something we're only going to use if we're currently making if we're currently in debug mode. Whoops, let me keep the order the same. So if we're using debug mode, then go ahead and call that link script, and we'll call main from there. If we're in let's pop that in there for simplicity. If we're in release mode, we're going to do something more like this. We're going to do something very similar, but instead of loading in the link and then executing it, we're going to load in something called s.luac. So our scripts that are compiled, whatever our application is named, we might name it app.luac, whatever, doesn't really matter. The compiled stuff just has to match whatever we name this, and then it will load in the compiled versions, execute that, because we're basically going to load in that proto. We'll automatically have a proto. We won't have to compile the proto, and then it's going to call the proto, and that calling that will, amongst other things, define the main function so that we can call that, which up here was a very similar process. We loaded in the Lua file, the link file, which then got compiled. Then we executed the link file right here, and by executing the link file, we loaded and executed everything else. So this basically skips a lot of steps by going straight to executing everything else, where here we have to load link, execute link, load everything else, execute everything else, and finally the mains are identical, which is what we want. We want at some point things to become identical, and we want them to become identical once the program starts. So now all we need is a mode for the compiler, which is kind of the in-between state between these. So in the compiling, we can use a more straightforward approach. We can go with lua-l load file s compiler.lua semicolon, and then lua call, and that's all we have to do. We don't need to, we can just go with the script as executable rather than script as definition of main with the compiler. So let's run our compiler for C++, compile this debug mode, and there we go. So that mode works. Let's switch to the compiler now. Alright, so we're going to need a compiler script. Let's make that. The weird thing about Notepad++ is that you have to type something before it will allow you to save. Just a weird little note there. So compiler.lua. Okay. Compiles files. Now, when the compiler.lua script is being executed, we have a guarantee that we also have the compiler stuff registered. So we can just do begin. Let's see, we can do compile, and we need to use the name S. We don't want to strip debugging for now, because we can, what's interesting now is we can make compiled versions for debugging, and maybe until you are actually releasing it, maybe you're making compiled versions to make demos, you would keep the debugging information probably so that you can get good error messages. You'd only ever strip it if you wanted maximum efficiency and you didn't need the otherwise, like if you don't need error messages, you can still keep them because maybe they'll pop up and you'll be able to fix problems. Even if you're releasing, unless you need maximum efficiency, I wouldn't strip the debug information. Now, what we're going to do is we got to call add file on all of our files. So main add file secondary. Now we don't have to add the linker because the link is sort of the compiler.lua of the debugging mode. But here we have sort of an interesting issue. Let's say I am working on an application and I've just been developing for a while and I've lost track, but I sort of scattered and added like 20 new Lua scripts to this application. I was just defining a ton of new um, binding stuff. Maybe I was doing some config files. I've got all these different things that I've linked to, and now I've got to come over here and redo a ton of work to make the add file stuff. And they're going to be identical, right? So my link stuff and my add file stuff and my add files are going to be the same. This is why I kept this use file function. I could have just required these, but by making my own function called use file, anytime I need to go through all of these scripts and do something to them, I could just replace whatever function I want to call with them with use file, and then define use file however I need it to be defined. So that would look something like this in this case. Add file n. So now, instead of putting everything into a list of things to require, as I'm doing in use file, and technically yes, I could just be requiring directly, but I had other reasons at one time to do it this way, and I still prefer this way. But now I'm defining use file over here to be the add file function instead, basically. I'm saying use file, you're basically going to just add file, and that's what it does now. But since I'm doing this, there's one more step we can take to make the whole thing properly generic and very scalable. We can make one more script, call this file enum, and we're going to save that as a Lua script. And we're going to take out the use files there, and all this is going to do is call use file on every single name that needs to be included. And then no matter which version of the game I'm running or application I'm executing, whether it's debug, release, compiled, scripts only, no matter what system I'm using, even if it's some wild other thing, which is completely reasonable, or if I need to go through all of the files to copy them, anytime I have to do something to all of the files of this program, I can just call require file enum. And what file enum will do is call use file on every file in this program, and I can define use file beforehand to do whatever I need to do to each file. So in this case, to each file name, I want to add it to a list, and then later I'm going to require in all of those. Whereas in the compiler, I'm going to go through here, and once I've required file enum, it's going to add all those files to a compilation unit and then compile them all. So now, anytime I add a new file to the system, other than these three, of course, link, compiler, and file enum, if I add a tertiary file, I've got main, secondary, if I add a tertiary, I can just go use file, probably spelled that wrong, and suddenly it's available both in the debug mode with scripts, debug mode with compiled scripts, release mode with scripts, release mode with compilation, although there's no such thing as release mode with scripts. Anyway, that is the basic setup, and this is the setup I will stick by. I suggest any large-scale project has some sort of organization similar to this, just because, especially if you're going to start using the compiler, it's important to be able to control the order of things in which the order in which things happen. And even though it feels at first like entering from here and executing one line at a time gives you more control of the order, it's actually not true. By separating the order in which you define things from the order in which they happen, you give yourself a lot more flexibility and expansibility. And by having this file enum system, you have the ability to define new behaviors like linking or compiling very easily, simply by redefining the use file function every time you require this file. Now, the only other thing you might consider is that because file enum might need to be included twice, you should probably do file. If you require the same thing twice, nothing happens the second time. So do file, which requires the .lua, it might be a better option. So anyway, that is our little rundown um, of how to get your project set up. If you're taking my advice anyway, and of course you can feel free to come up with your own solutions, come up with your own systems. But this is, if you're looking for a good way to make a good scalable project setup, this is what I would do, because this is something I worked on for a while, and this is how I stick by now. This has served me well for a while. So next time we'll be looking into how we can get ourselves better debugging information for these projects. Alright? So, see you next time.